There's no denying that there's nothing quite as sweet as a clean 3D printing time lapse. But what does it take to achieve that? There are a range of options to choose from depending on the kit you have and the skills you can call on, but the truth is, there is no one correct method. I've been asked a few times about how I achieve my time lapses, and what better way to show you than to give you a little tour of my setup. Let's make some movie magic. Let's start with what you use to shoot your time lapse. I happen to be the owner of a slightly outdated but still perfectly good Fujifilm X-T10, which is a mirrorless camera, much like a DSLR. Shooting time-lapse with a traditional camera is not actually done through video at all, but by taking a single photo for every printed layer and stitching it together into a video at the end. Since the Fuji is a bit older, it lacks the ability to be hooked up directly as a webcam into something like Octolapse, which automates the process. I also don't have a great deal of soldering skills, so I'd quite like to avoid any methods that involve direct wiring into the printer. With these limitations in mind, I think we are able to move on to part 2, the triggering mechanism. Since I already established that I, 1, don't want to solder, and 2, can't connect directly into my Raspberry Pi and Octolapse with my camera, that means I needed to consider a mechanical method of triggering the camera to take a photo. For this, I turned to a wonderful friend and someone who has gone down this route before, Andrew Sink. Andrew has a Prusa Mark III's just like mine, and that meant I knew he would have some great advice on how to rig up a remote to the printer. Not only did he share files with me to give me a place to start, but he ended up being an immense source of help on this. Thank you, Andrew. When I did research into additional kit for the Fuji, I discovered a great affordable wireless remote that would do the job perfectly. The receiver sits nicely in the cold shoe mount of the camera and plugs directly into it, which then uses the radio signal from the remote to trigger the camera shutter. Andrew's design to mount the remote to the X-axis motor on the Prusa Mark III's was a great place for me to start, as I also wanted to attach my remote in the same location. Since we were using different photo equipment, I had to make adjustments to the design in order to make it work with my kit. Thankfully, this was a simple enough process with Fusion 360 and a wonderful base model. The final element to the triggering mechanism is effectively a poking stick mounted directly to the extruder, replacing the stock top cover that the Prusa comes with. It doesn't even require a different screw to attach it. Perfecto! Mwah! Now that we have the pieces required to physically make the camera take a photo at the end of every printed layer, we need to look at part 3, the G-code. If you've spent any amount of time getting acquainted with your 3D printer and how it works, you might know that the computer programming language that it uses to create your prints is called G-code. If you aren't familiar with G-code, it's actually not exclusive to 3D printing at all, but is a standard language used across many computerized machine tools that control a range of motor movements as well as additive and subtractive processes. It uses an array of letter addresses to tell the machine what to do, and we're going to use exactly this to tell the printer to take photos for our time-lapse. Most 3D printing slicers have a section within the settings that allows you to set your own custom G-code. And for Prusa Slicer, which is what I use, it can be found under Printer Settings, Custom G-code. Some people choose to put their custom time-lapse code in the Before Layer Change section, but I prefer the After Layer Change section as it yielded better results. With that being said, I must mention something important. The G-code I use for my time-lapse setup is not a one-size-fits-all G-code. If you copy what I have written exactly into your own slicer, you will not get the same results and may even damage your printer. Please do your own research for the settings required for your printer. Please. The G-code required for my setup with the manual trigger is not terribly complicated, as you can see from the comments next to the code. It is done entirely with different G1 and G4 commands, which control the movements and pausing of the printer. The code you see here tells the extruder to retract the filament, Move the print head over towards the remote while moving the bed forward into photo taking position. Wait briefly before moving to press the trigger button, and then waiting again before releasing it. Lastly, before it resumes printing, the final G1 command tells the printer to prime the extruder so it can pick up printing where it left off. C'est fini! This small handful of code is what makes the camera trigger fire at the end of every layer, giving you that incredible, magical transformation of the print simply growing out of the print bed like an enchanted weed. And that's it. That's how I create my time lapses and make amazing little clips that you... What? What's that? What do you mean I skipped a bit? I skipped a whole bit? You want to know about the lights and the camera settings? Ah, jeez. Compiling the photos into video too? Oh, come on. Creating a lighting setup for your time-lapse is an essential part of achieving crisp and consistent images that aren't affected by the rising and setting of the sun. Like all previous steps, what works well for me isn't necessarily going to work well for you, and is simply what I have found to be best. I've gone to the trouble of adding a lovely LED light strip directly above my printer, which draws power from the printer itself to provide close-up, consistent lighting for my print bed. Of course, if you already know about good lighting, then you know that one light is never enough. I use one of my big, newer soft boxes as a fill light in conjunction with the LED light. As you can see, the difference between one or two lights might not seem like much from where we're standing, but you can definitely see it from behind the lens. Though, this reminds me of something. If a picture is worth 1,000 words, and a single time lapse is made up of hundreds of photos, I don't think you need me telling you that dialing good settings into your camera is a rather crucial step of the process, right? Of course not. I would need several videos to give you a thorough rundown of all the important details on a traditional camera, but I can mention a few key settings to bear in mind when you're setting up your shot. This is what works for me. I focus the lens on the center of the bed, but aim to have the background be as out of focus as possible, which means setting a low f-stop to create a short depth of field. This will in turn make the shot dramatically too bright if your ISO began at any reasonable mid-range number. I crank that down until the brightness is more manageable, which for me is usually around 200 ISO. I also set my focus from automatic to manual, so you don't need to worry about the camera wasting time refocusing before each shot. Finally, I take a couple of shots, test the remote is working, and check that everything looks right and is in focus. Okay, now we're ready to start. This is going to take a while though, so let me just get out of the way here. Once the print is finished, the memory card collected from the camera, and the images emptied out on the computer, it's finally time to turn this picture show into a real video. This can be done with any video editing software that can import image files as a sequence. I use a software called DaVinci Resolve for all of my video editing, and time lapses are no exception. Each video editing software has its own import process, so make sure that your images import as a sequence instead of as individual files. After that, you're free to add those final finishing touches and edit to your heart's content. I like to check the image sequence for any weird print layers or digital glitches, increase the playback speed if it feels slow, crop the image to fit the composition a bit better, and perhaps tweak the colors as needed. None of this is required, of course. You are free to do as much or as little as you'd like to your completed time-lapse. Render it out into the video format of your choice, and then... There you have it, the real ending of the video. There's nothing else that you'll ever need to know about how to do a time lapse. It's all here, all the knowledge, nothing missing, nothing! Seriously though, I hope you've come away from this video knowing a bit more about creating awesome time-lapse sequences. There really are so many ways to do it, and I'm thrilled to be able to add my experience into the mix. If you know of any other great time-lapse setup videos or tutorials, please share those links in the comments below. I always love to see what others are doing in this area, as well as perhaps how I can improve my own setup. After all, sharing knowledge is how we give back in this community. The important cycle of giving and receiving is what got me where I am now. And I'm pretty thankful for that. Speaking of being thankful, this video has been made possible by 3D Musketeers, offering full-service product development, prototyping, and production to help you make awesome, from art to part. Links in the description. Until next time, keep creating.